And that's going, okay, and now I will hand it over to Walt, who is the chair of the New York Citizens Advisory Committee, to welcome folks and explain a little bit about what the New York CAC is for the non-members in the room and online, and how you might get more involved.
Great, thanks very much, Katie, and thanks for helping pull all this together. I'm Walt Lender. I'm the chair of the New York CAC, and that makes me also a member of the Lake Champlain Basin Program Steering Committee. The purpose of the CAC, and Katie, you'll have some materials to hand out that gives a little bit more detail, but our purpose is to be a group of citizens who provide feedback to the steering committee and bring issues about Lake Champlain back to the steering committee for their action, so that they understand what's going on in especially on the New York side of the steering committee, the New York side of the Lake Champlain Basin. We have a counterpart on the Vermont side as well. They operate a little bit differently. But our purpose here tonight is to do some outreach with the public and to gather information on the part of the Citizens Advisory Committee members. And then whatever we glean here, we will bring back to the steering committee. At this point, we typically ask if there are any members of the public who wish to make some comment, since this is an open meeting.
An invitation for public comment online and related to Lake Champlain, not just any.
Well, thanks. Sounds like there is none. So, Katie, I will turn this back to you to introduce our esteemed speaker tonight, and we're very, very happy to have Tim here to share with us his research on microplastics. Thank you very much.
Thanks, Walt. One more thing. So Walt mentioned the Vermont Citizens Advisory Committee. There's also one in Quebec that we coordinate with. That's all right. We work a little more closely with the Vermont Steering Committee, or not Steering Committee, Citizens Advisory Committee. But all three CACs will work together sometimes to try to push different initiatives forward. And we've seen really good success of that citizen effort through this Technical Advisory Committee at the Basin Program put out an RFP for someone to create emerging contaminants monitoring protocol, and that came out of a request from the Citizens Advisory Committee. So this group, these three groups have a lot of power, and it's a really great way to bring community voices into the management of our shared waters. And there's a RAT card on the back table and the CAC's 2024 focus document, which highlights their priorities for the year. If you're interested in taking a look at those, I'll drop them in the chat as well after our speaker starts. So without further ado, I'd love to introduce Dr. Tim Mihuc, who oversees Lake Champlain Sea Grant SUNY Plattsburgh operations and also serves as the director of the Lake Champlain Research Institute at SUNY Plattsburgh. He started his career in water looking at nutrient limitation on algae and small eutrophic lakes in Oklahoma. He continued that path as an aquatic ecologist through studies on invertebrate life history ecology and Colorado alpine wetland and post-fire food web dynamics and Yellowstone National Park streams. He also spent several years at Louisiana State University conducting invasive species research in the largest contiguous hardwood swamp ecosystem in the US, and he served as the director of the Great Rivers Field Station, where he led a multidisciplinary research team on working on the upper Mississippi River. And I'm sure this is out of date. This is from your Sea Grant bio. I am going to say that you've published well over 35 research articles in journals, and it's done a lot of really great work on Lake Champlain issues, and we're going to hear about some of that tonight. And I wanted to ask you, Tim, what is your favorite way to enjoy Lake Champlain?
Sampling at night on the boat at the research buoy.
Nice.
With loons in the back.
That sounds like a pretty unique experience. So we'll welcome you up now to start your talk on microplastics in Lake Champlain. Thanks so much for joining us, and we're really excited to hear from you.
Thank you so much, Tim.
Thanks, it's good to be here. I see a lot of familiar faces, some of whom I've actually known since I arrived at Plattsburgh. My colleague Jim Dawson from my department. Vic and I served on the TAC for I don't know how many years, Vic, but it's good to see you. Former student who's been on the boat, someone else I've known since I've been at Plattsburgh. Yeah, so it's kind of a familiar crowd. Other people that have been grad students at this is a good group. So I'm here to tell you a little about our new study going on between University of Vermont and SUNY Plattsburgh We're just in the beginning of it, but I'm gonna run down sort of what our study design is, a few things about what we're finding. We'll get to more of that after we have a field season under our belt, and
sorry, the screen
talk a little more about
shares.
data. Oh, geez.
Yeah, it looks good there, but not on the Zoom.
Oh, I am technologically illiterate.
Sorry, we'll figure that out. I think this is also the New York CAC's first hybrid meeting, so thanks for sticking with us through these screen shares.
That's what I do. What you just did. I think it's there.
Okay, now, once you've got this up, go ahead and start the show. Go up to slideshow and say start with the current.
Yeah, so that's what's showing up on there. You're still seeing the, I wonder if I have to like share the whole screen.
I've done that before too.
Yeah.
Are you?
The whole desktop and then Zoom in.
Yeah, I would do that.
We were a Zoom campus during COVID, so in theory I should know what I'm doing. I've done that trick you just did. That's going to take
There you go.
There,
Oh, you're good.
Oops, well, that'll work.
Yeah, great, woo, okay. Thanks, everyone.
All right, we're back in business.
Yes.
Brings back memories of a few years ago. Well, we taught all our classes that way with only one day notice. Literally, tomorrow we start teaching online. Thank you very much. So anyways, our colleagues, myself, Danielle Garneau, is a wildlife ecologist at SUNY Plattsburgh, many of you know. Dr. Aude Loche, who works with Lake Champlain Sea Grant. She's in New York as the outreach extension person. And Ann Jefferson, who's new at the University of Vermont, head of the Lake Champlain Sea Grant program. So a lot of Sea Grant people here, and several Plattsburgh people, but a joint project between University of Vermont and SUNY Plattsburgh. So I'll introduce to you just a little bit about sort of the why. We had, Danielle in particular, had a couple of Sea Grant funded projects and looking at microplastics between 2012 and 2015. Other work going on in the Lake Champlain Basin includes work from the Rosalia Project, folks in Vermont have been doing beach plastic modeling back to 2014. We had noticed in our lake samples some nurdles, and actually I'll do this now and pass these around so they can make it around the room. I have two types of plastic beads from the Plattsburgh City Beach, nurdles from the water in the lake, and for fun, I brought you a vial of the spiny water flea, which was made in 2014, and Lake Champlain, something we studied a lot at LCRI. But this study really comes from the fact that there's been some previous work. We know there's plastics out there in the environment of various types. And then we had several classes, my class and Danielle's classes, and noted particularly in 2022 in our classes, a ton of those beads that are going around the room. The little white beads on the Plattsburgh City Beach. So many so that we realized there were literally thousands of them. And you said, we got to figure out what's going on here. That led to the germ, the idea for this research grant, and talking with our colleagues and saying, hey, what do we do about figuring out the distribution of plastics in the Lake Champlain Basin? And we decided to focus on beaches, the tributary rivers, and the lake itself. And so the idea here is if we can get a sort of think of a GIS spatial map of plastic distribution in the lake, in the beaches, in the rivers, maybe that will lead us to, at the end of this project, some ideas or maybe even some hard information on the sources, pathways, and sinks and sources of these plastics. Once we find them, we kind of want to know where they're coming from, or at least get the best estimate of where we think they're coming from. For instance, we find a huge concentration of plastics near a certain river. We're going to want to then look in that river and figure out where they're coming from. And if we can do that, hopefully then addressing that issue would be the ultimate outcome of this project. Like I said, we've been finding these buoyant microplastics in the lake. Those are the little black rubber pieces in the vial I'm passing around. We want to know more about river transport, and we want to know more about beaches. There's some examples here. These are the rubber nurdles here. There's some examples here of some of the types of plastics that we have found already. We won't do too much of this, but in our work plan, this shows you our task for our project. Our start date, which was a little late, and that had to do with contract issues. And then what we're doing for the next 2 years across these 6 tasks. We're gonna identify our study sites and do our sampling designs. That's been done for year 1. We are sampling right now. We're gonna collect our year 1 data. That's going on right now. We'll do a data analysis of that data, which will then tell us what sites we want to focus on for more intensive sampling in year 2, and understand the distribution. So this is just briefly our tributary sites. We're going to do 10 sites between New York and Vermont at 5 sample dates, and that's going on right now. And then we're going to hone in on 3 to 5 sites at 10 dates for year 2. We're going to get to know more about the plastics in the rivers where we find the most plastics. The lake is pretty set because we're following samples from the long-term monitoring program. They have 15 lake-wide monitoring sites, so we're looking at that this year across 5 of their sample dates. They have 10 total. I should say we, because we do this work for New York at LCRI. And then in year 2, we're going to focus in on some of those lake sites and go to all 10 dates and look at the plastic distribution, particularly those black rubber noodles that are in the bottle and sending around. And then beaches, we have 12 spread between 6 in New York, 6 in Vermont. They're mostly the public beaches like the city of Plattsburgh, the Ausable State Park, Point and Rush, the ones where there's a lot of public use. And then we're going to hone in on several beach sites for year 2, the ones, again, where we're finding the most plastics. This kind of describes our collaboration with Vermont. For right now in our lake sampling work for year 1, and then river and beach sampling going on. And we're going to look at that data over winter. We brought in our 2 new graduate students, a master's student at SUNY Plattsburgh, Allison Morrow, and a PhD student at UVM, are both on board. So we have our funding, we've got our students, and we've started our work. A little bit of introduction. This is all thanks to my colleague, Danielle Garneau, who literally is the expert on this method for us at Plattsburgh. But this is essentially, if you find a piece of plastic, you want to know what it is. You can look at it and go, oh, it's a fiber, it's a film, it's a fragment, whatever. But Danielle, in our chemistry department, we have an FTIR, which is basically an infrared instrument that lets us bounce light off it and look at that, and it'll tell us, based on what comes back from that light that refracts off it, whether it's polypropylene, PVC, acrylic. We have standard databases that tell us when it comes back what the signature is. So we're taking every piece of plastic and running it through the FTIR and determining exactly what kind of plastic it is. That's a part of this project. That might help us find the source. So I'll briefly go over some things. This is the lake, and I'm pretty partial to the map over there on the right because that's the lake monitoring map. So if you're involved in Lake Champlain and you see the phosphorus data, for example, it's coming from those 15 black dots. We sample that every 2 weeks for 10 weeks for the whole summer. We sample the tributaries at least 15 times throughout the season. So the tributary phosphorus data and the lake phosphorus data, they come from those points. Yes, someone had a question. Yep.
Yeah, I'm just wondering, I haven't heard the term nurdle before. Is a nurdle like a piece of plastic that looks like a grain of sand?
It's kind of a generic term. Actually, those beads are also called nurdles. So it's just something that's small. It's a piece of plastic.
Okay.
Typically, what it is a pre-production industrial plastic is typically what a nurdle is. You can buy those by the millions and have them shipped to your industry so you can melt them down and say make a snowmobile track or whatever it is you're doing. That's where they get their plastics. They get them in small little pieces that they buy that the industrial sources come from. That's a pretty good question. And so anyways, those are the LTM sites. If you see all the phosphorus data, whatever it is, it's coming from those sites, sampled by both Vermont and New York. So we are going to make use of those sites, including the tributary sites. We're using the same ones that the nutrient data comes from. And we're using the 15 black dots. We're using those samples actually from LTM. When they're done with their sampling, we have it in the lab. My kids have identified the plankton or counted the spiny water flea or whatever. We're then looking in that sample for plastics after they're done with it. So we're taking advantage of another program this would save us a lot of money because we're not having to spend all the money of this project to go out in the boats and do all this sampling. We are utilizing LTM, which is one of the largest things funded by the Basin program. This is new for us, which is net sampling in the rivers. And some of the other things we might do. with a sample when we get it. This is again, Danielle's area of expertise. We might density separate the samples, which is simply just using a solution, and then some of the stuff will float and some will stay down. That's what density separation is. We might do a wet peroxide oxidation. We'll use sieves to side separate, particularly our beach samples. We might do a raw nurdle count, for instance, in the lake samples, and we characterize a subsample. And eventually, when we get a polymer or a piece of plastic, we don't know what it is, we'll go to the FTIR and we'll get information out, particularly what kind of plastic it is. We know that for a lot of them already because we've done it. And again, this is the river sampling, so that would be the river trips for LTM. We have a drift net, a 250 micron mesh net that we run at those sites. We're doing, like I said, 5 dates this year, and we're almost done with that. We finished that out this fall. And then we're doing the lake plankton sampling is here, shown here. There's the vial of nurdles. I think it's the same vial that's from the lake. I guess I'll talk briefly about that while that vial is up there. It's partly what drove the impetus behind this project is, like I said, this work is done at LCRI for the state of New York. And we have seen these for a long time in the net samples, and we start looking and we're like, oh my God. And then we figured out what they are, and Danielle helped us. These are distributed throughout the whole lake. We have a site where we do vertical sampling at a 200-foot deep site at Valcour, the data buoy. And we find these 200 feet down in the lake. We find them at 100 feet. We find them at 50 feet. We'll pull up a vial. We'll pull up a net sample. There's 5 of them in the jar. These are all over the lake. Every fish in the lake with an open mouth is swimming through that. Bees floating in the lake. This is the most disconcerting thing I've seen in my career working on Lake Champlain. Plastics floating in the middle of the lake that we didn't know were there until we started to look for them. And hopefully we're going to quantify that distribution, where they are. Maybe they're more concentrated in certain parts of the lake, like Main Lake versus Inland Sea versus other places. Hopefully we'll figure out maybe where their source is. We have no idea where these things that are floating in the lake have come from. There are probably millions of those in Lake Champlain. All right, so to keep going, some of the post-processing, here's the output of an FTIR plot, involves some pretty serious chemistry in the sense that we're doing some pretty serious oxidation techniques to basically burn off all the organics and leave nothing but inorganics, which leaves us the plastics to count and process and determine densities and what type of plastic they are. And this is beaches. Beaches really is a big part of this study. No, other than Rosalia Project, who's been looking at beaches, we haven't really looked at our beaches in Lake Champlain. We don't really know what's there. This is the Plattsburgh City Beach. That plus the state park in Plattsburgh, a lot of people don't know this. It's probably well over 2 miles long of one of the sandiest beaches on Lake Champlain because it gets all the lakelands. We've been there in those conditions. And some really nice dunes, which have Champlain seagrass on them, at least part of them. This is the longest contiguous beach, freshwater beach, I think. Caveat, maybe it's not true, but I think in all of North America, this is the longest continuous freshwater beach. If you get a chance to go there, it's a nice one. Anyways, we're looking at with our grid sampling, 25 centimeter square grid. We take it down to 10 centimeters depth, and that's all getting in the lab. We got to filter that. We got to sieve it. We got to figure out what plastics are in it. We did a fun aside from this project the other day through Sea Grant, where we brought 157 7th graders from Beekman Town School in the New York side. We brought them to this beach and we all had them do all the grid sampling and had them, we found a lot of plastics that day with 150 people looking. There's quite a few plastics on these beaches. So our study is going to at least get a handle on that, particularly at the one shown over there between Vermont and New York. Like I said, the beaches that have more public use, we want to get a handle on what's there. What's your kid playing in the sand when they go to the beach? And maybe can we figure out the source of where that plastic is coming from? So as part of the beach sampling, Danielle has this really cool, she's pretty good on the technology, if you know Danielle. And so there's a whole app on the phone. Each grid that they take a picture of, it gets geo-referenced and geo-located on the app. So all our field work is essentially, there's this electronic data entry that goes on in the field with the date, the time, the type of sample, the images that are taken, and other field notes. So it's kind of cool. We have this electronic field note system going. And if we go to a beach and start taking replicate samples like we do, 5 samples at each beach, we generate a lot of trays of sand. We have to carry that back in a cart. There's a lot of work going on to sample the beach and figure out what's there. And we are finding plastics on the beaches. I can tell you more about what those are once we started to process the data. But here's the sand in the lab. We dry and weigh it. We size separate it on sieves. Then we have multiple categories of size. There's a piece of plastic in a sieve over there. Here's a typical, it goes in a pan. Once we collect it, there's a typical sample. And then in the lab, processing, then we characterize it, we'll count it. Like I said, if we don't know what the polymer is, we'll go to the FTIR and determine it for new pieces. There's a few things that we might find. Some of the things you'll probably find if you look for plastics, you'll find foam from broken up from docks. With those 154 kids from the school, we found the blue foam from people who had blue foam on their docks. We found the white foam from people who had white foam on their docks, all broken up, usually in very small sizes, but this stuff was all over. When a dock breaks up, the lake then breaks it up more through the wave action and currents, and it ends up washing up on shore somewhere. That's a pretty common thing. Here's the beads, which some call nurdles, but I like to call them beads. We found a lot of these, particularly so far at the Plattsburgh City Beach. They're coming from somewhere. Biggest thing we found was last winter, before this study started. I have one of my kids lives over there near the beach in Plattsburgh, and I was visiting him, and I went down to the beach to look because I knew we were going to be looking at plastics, and there were 2 55-gallon plastic drums washed up on the Plattsburgh City Beach. Somebody's dock broke up, and their stuff just blew all the way across the lake. And like I said, it all ends up at the Plattsburgh City Beach. With the fetch of the lake, it's just headed straight for Plattsburgh. We got those drums and we took them out and we disposed of them properly. Aude Loche took it on herself to make sure those drums were taken care of. And the other interesting side of that, before I get to this brief data, is something really cool going on at Plattsburgh right now. If you're interested, there are 2 artists visiting our art museum on campus, and they're theming their art on plastics and pollution. One of the exhibits, again, is coming up in a few weeks in October. But there's 2 visiting artists at Plattsburgh through the art museum. And if you're interested, let me know. I'll send you links to that. But we helped them, Aude in particular, we helped them get some plastics to use in their art. And they talked to us a lot about this issue. And so it's pretty cool to see the university, the campus, doing something over in art that's related to this issue. Very preliminary data of some of the beaches, mostly the New York side. And the different types of plastics, you can see densities there, and then different types across the different sieve sizes, bead, nurdle, foam, film, fiber, fragment. Yeah, we're finding plastics on the beaches, some more than others. Like Point Roche didn't have a high density compared to, say, Ausable or Plattsburgh or other places. More to come on this as we get more data and we can sort of talk about where the hotspots are. And I do want to end with the idea that this project involves Sea Grant staff, it involves outreach. Part of what we put in the grant proposal was to do some citizen public outreach. We plan to, especially once we have more data, but we've already even started working with citizen groups, engaging scientists in the collecting of the debris, talking about our data. At some point, when we know where plastics might be concentrated, we're going to need to engage municipal leaders and businesses. And if we can identify the sources and try to deal with that with our communities, working with them, we have the data. We want to share the data. Maybe that will lead to some change and how the industry might work. Again, collaboration with artists, which has been really cool. It's kind of starting right at the beginning of our project. And then lastly, to begin to develop educational materials. And our Sea Grant program has another funded project by the Basin program, our Watershed Education Group. And the focus of that for the 2-year period of the recent grant is going to be going into the elementary schools and looking at plastics as an issue with elementary kids. The more we do it, the more people will realize there are a lot of plastics out there. Now with my lens, because of this work and Danielle's previous work, every time I look somewhere, all I see is plastics. Ooh, that's plastic, that's plastic, that's plastic. Why do we have that? Why do we need that? I think the shirt I'm wearing is probably polyester, so it's plastic. And I'll leave it at that and answer any questions you have or concerns or, yeah.
Just an observation. You mentioned that there's a lot of plastic at the Plattsburgh beach, but very few at the beach in St. Andrews.
Yeah, some beaches will have
They both face south. They both get the same kind of wind.
Well, we don't know. Right now, we know more about Plattsburgh because we've sampled it more. That's essentially a bias on our part. We have sampled that prior to this project. But there will be probably some beaches where there'll be more and less. Yeah, that's a good question. Any of those beaches with the south facing the fetch of the lake have the chance for all that debris to end up there. So it'd be interesting to see. Right now, we do know we're seeing a lot washing up in the Cumberland Head area and Plattsburgh, because like last week when the lake had like the best wind conditions for 4 straight days that I probably have ever seen. And we have a storm study going on, so it was really perfect for that study. But we were at the beach with those middle schoolers on one of those days, and just that you go to the Plattsburgh City Beach when it's moving and you get 3 or 4 foot waves. That's how those dunes got built. And it concentrates and brings all the debris. Plattsburgh is like this perfectly situated. It's the reason those dunes have been built, is that wave action. So.
I have a few questions. What do you do with the plastics once you find them? Like
do not put them back. Essentially, right now, any sample we have, we keep it. Once the sample's processed and done, we keep, because we're quantifying it. But like with the school groups, that's a good question. We kept it all. I was like, I forgot to figure out where it was. I was going to bring it here and show everybody how much we got of it. But I have it. It's in a pan. I just couldn't find it in the lab, and who knows? I didn't know where it was yet either. So yeah, we don't put it back. It's like when you catch a fish, you release it. We don't do that.
Tim, you might have mentioned this, but you've been sampling the lake for decades through city and LCI. And I think, rumor has it, you still have your old samples neatly organized in your case. And I'm just wondering if you've had a chance to figure out how far back the plastics go.
And that's a really good question. Danielle did some of that with her previous projects, but we have every plankton sample collected on the lake back into the 90s. So yeah, we archive it all. It's something we're required to do as part of the mining program. So one of the potential uses of those samples, because it's the same net taken the same way and the same sites. Yeah, that's something we thought of, is going back in time. We're currently going to use the LTM data from this year and next year, but as a precursor to this project, we had been counting the minerals in those samples for, like we did it for all of 22, and we did it for all of 23. So we'll have a little bit more data. I have at least 4 good years of data that we could go back. It's a lot of time to spend to go back and look back, because there are literally thousands of those samples. But that's a really good question. We have archived at campus all of those samples for the plankton all the way back for a good 30 plus years. Yeah.
Is there enough of a signature in the type of plastic to be able to trace back and find out who manufactured it and what kind of product?
Potentially, with the 2 that I'm circulating, the nurdles and the beads, I could probably do a little searching online and go and figure out where I could buy those. And then if I say bought some and compared the FBIR signature, I could probably say, yeah, those are the same thing. And I have an idea what type of industry might be using it. The one is a harder plastic sort of bead that you would probably melt down and make like a plastic cup or something else. The other one is more rubber. If you get them in, you can squish them and squeeze them. So that's probably more for some type of rubber.
We might be able to manage the products that are coming into the basin if some are putting more stuff in the lake than others.
Yeah, no, we could figure out like if we knew how they were shipped, if we knew where they were going. That's where this community would get involved. That's where you folks would get involved, because you might say, hey, maybe we should ask it to be done this way. Maybe these plastics should not be spilling out and over, because they certainly are now getting in the environment. I mean, whatever's going on, those beads are washing up on the city beach. So they're coming from somewhere.
I just have a clarifying question. So when you're talking about these turtles, you're saying you're collecting those, is that how they're showing up, or is that they're being worn away to that point after being plastic that's present in the plastics?
Those are showing up on the beach that way, and they're not really worn away. You can buy those now and
So
those are yeah, so these are not, and the nurdles in the lake, they're all the same. They're all the same size. They're the same shape. It's not like they're not really breaking down either. It's the kind of stuff you would buy to make something out of.
It's an ingredient, like you would have to add things to make it into different kinds of.
Yes.
We do have a couple of questions online.
Sure.
Make sure we get to before we get back to the folks in the room. So Tom Metz, you have your hand up. Do you want to ask your question?
Yes, yes, please. Tim, you were talking about the nurdles being all the way down in the water. Oh. Excuse me, all the way down in the water column, and fish can just sort of swim along and gather those in. Have you been able to get any marine biologists interested in finding out what density of nurdles or other stuff is showing up in the fish, other critters in our lake? Over.
That's a good question. And actually Danielle has got a project she's been working on for years to look in fish guts to see what's there. So we're working on that. It's not part of the scope of this study, but we're very interested in that question, especially because those floating nurdles are out in the lake at all depths. And alewife are feeding as forage fish, and smelt are out there feeding as forage fish. They're feeding on planktonic food that's about the same size. So we want to know if it's moving. Typically, it probably would get ingested by a fish and then maybe move through the fish. Wouldn't necessarily stay, but if you have them in the fish guts, you can maybe see, how many they're ingesting. Who knows what that impact is, right, on a fish that's feeding on that? It's kind of like eating salad. It would have no food value for them whatsoever. There'd be no calories in it. If it's passing through, that would be okay. But if it's passing through and there are other chemicals attached to it, because these might be hydrophobic or hydrophilic plastics, then we might be concerned. Other chemicals are on those plastics that the fish is then ingesting and might actually get into the fish tissue.
What's the solubility of those plastic nanoparticles?
I don't know the answer to that. All I know is that they're buoyant and they float, and they're there going back at least several years.
But do they dissolve in the water?
No, they seem to just be around. And part of the problem with plastics is, right, everybody knows plastics comes from oil. Just to be clear, where plastics are made, they're part of the oil industry. They're a byproduct of the oil industry that some chemists said, oh, we can do cool things with. And that happened in the 40s and 50s, and now we all have plastics. So they don't break down. They're relatively inert. It takes thousands of years to break down a piece of plastic. That's the problem with plastics. they're not naturally organic, and they don't break down. Yeah.
And a question on whether or not there's a way to assess whether it impacts dissolved oxygen or biological oxygen demand or any other chemical, process.
Good question. Probably not, given that they're out there already, and so whatever chemistry in the lake is going on with those there. We don't have a lake to compare without them. To ask those questions, that would be more of a lab study too, where you'd be, hey, what if I had, water with and without? What's the changes in chemistry that would occur? So we can't really address that on Lake Champlain because Lake Champlain already has these plastics in it.
Yeah. Follow-up question would be, is there a way to test like stormwater, obviously sewage treatment plant, effluents,
And Danielle had done some work in sewage treatment plants, looking more for the smaller fibers. But the one of the ways we might could track these larger macro type pieces is to look to see if they're coming in through stormwater. You know, and that would help. It would really help if the stormwater were separated from sewer water to do that. Unfortunately, that is not the case in every city. It's more the case in Vermont systems than it is in New York systems for sure. So when, you know, if stormwater is flowing to the sewage treatment plant, it's a lot harder to sample it and deal with it. Because no, we are not going down manhole covers and streets into sewage to try to sample for plastics. One, we wouldn't be allowed to do that. Two, you know, we're probably not going to do it for human health reasons.
We have a
okay.
So Rachel, do you want to ask your question?
Yeah, sure. Thanks. And hi, Rachel from Rosalia Project in Vermont. So one, thank you for doing this work. This is so exciting. And two, thanks for making this available for those of us who couldn't get over there on the other side of the lake. Yeah, so I just wanted to add a quick thing that, you know, we did similar, not as extensive work on just the dry and little bit wet part of beaches around Lake Champlain. And to the question that someone answered earlier or asked earlier, we did find more microplastics on the beaches that were similarly south facing in Burlington than we did in Plattsburgh. So it'll be really interesting in your study 10 years later to see if you guys have find similar patterns. But we too found incredibly large amounts in the kind of south facing near population center beaches. And this is also great timing for some baseline with the foam bill that just got passed, requiring encapsulating docks. So that's really great timing. And I wanted to ask, Tim, if you'd be open to adding a couple other characteristics for any fibers that you find to, and we can talk about it later if it's cool, but to include shape of the fiber in addition to just that it's a fiber. And that would help compare some of the work that we're doing all over the world, but also locally, to help differentiate sources even more than just saying it's a fiber, you know, like if it's a cylindrical fiber or square or bilobal or whatever. Is that something you guys would be open to?
Yeah, definitely. That's a really good idea. And like I said before, a lot of our project is based on some of the Rosalia work. It's going on worldwide, but has occurred also on Lake Champlain. That work had a lot to do with some of the ideas that we're doing.
Love it. Yeah, so psyched.
Thank you, Rachel, for your work.
Thank you for your work. So yeah, I'll get in touch later and we can talk about it. But I'm so excited this is happening. And if you guys need any other kind of support on the Vermont side, and we got people.
So Guy Parento put in the chat a question. The plastics disintegrate in smaller pieces eventually. Is there a plan to retrieve core samples and stable sediments to trace the history of this contamination?
Ooh, paleoplastics. They do break into smaller pieces. We've seen, you know, what we think are probably, we see the little plastic films, which are probably, and they're in tiny little chunks. Those are probably broken down plastic bags, which thankfully in New York, you can't use anymore. I don't care if you don't like using them. I'm glad you can't use them anymore. But yeah, we've seen what we think are those plastic bags broken down into little tiny fragments. So the short answer to that question is paleo takes a long time, and we haven't been putting plastics out there for a long time. So we're going to need a few hundred years to see plastics in the paleo record. They'll be in the surface sediments probably, but we could look there now and get some early data. But we need a few hundred years of sediment to then see, oh yeah, 150 years ago, there were a lot of plastics. 150 years ago, there probably weren't a lot of plastics because we didn't have plastics. Yeah. So
thank you.
Yeah, I'm just wondering, do we know what the human health implications are of the minerals? And when did you start finding those black minerals?
We've seen them now for more than 5 years. They probably go back, as Colleen pointed out. They probably go back farther than that in the lake. I don't know. That's a really good question. Human health implications. I don't know the answer, but You know, I'd leave that, that's gonna take a whole other study to determine. I would say, like I said, the single most disconcerting thing I get in my job right now is to be on the boat like I was last week, pulling up a sample from 100 feet down and seeing 5 of those nurdles in the bottle that's taken over a 15-meter sample, which is like 15 to 16 feet tall. And so it's not a high volume of lake water, and there's 5 nurdles sitting in there. And I'm like, why are these here?
As it starts to break down, there are also endocrine disruptors.
There could be hormonal endocrine disruptor. Yeah, there could be any number of things going on. All questions we don't know any answers to. Yeah.
I think there may be more answers. I worked with Danielle a little on some of the sampling she did in a previous project and followed up with on that exact question. What are the health implications? And there's a really excellent report called Beyond Plastics written by a former EPA regional director. His name is Janet. Somebody's going to find it in a minute. But the report is called Beyond Plastics, and she testified in the past year about to Congress about the health implications of plastics that do. Her research, the research behind which that report do document that the tiniest stuff of the nanoplastics do cross the tissue barriers in the health and primarily impact endocrine systems, but also can cross the placental barrier. Yes. So, yeah, that's the report is very good.
I was just wondering about the health implications if you get to drinking water from Lake Champlain.
That's also a really good question. Yeah, the only way we'd know that is if in that water we were testing for these various types of potential endocrine disruptors or other things, and I'm not sure how common that is done in our water supplies.
I think some of the health, I know on the New York side, some of the wastewater treatment plants do sample in their effluent now because of the work that y'all have done. And one of the biggest things that they found that I think Plattsburgh was the kind of poster child for reducing the outputs was by putting in a coarse grid, a coarse sieve where it comes in. So if you don't put big things in, they don't come out smaller on the other end.
Yeah.
And I think Plattsburgh reduced by like
I think you're right.
Of what was coming out.
It was fairly simple technology from what I understand.
Yeah.
Get big things out first.
Yeah.
It's a good idea.
Yeah.
So this is maybe more of a comment also, but it's really the thing that distresses me most in some ways is that I think of us as being at the top of the watershed. Like we're where the water's cleanest, right? I mean, the ocean, we get the microplastics are out there and people are doing great work in the oceans, but we're, what is it, 1,000 miles to the north of the St. Lawrence or 700, whatever it is. Like, if we have this kind of pollution at the top, what does it mean when our waters hit the St. Lawrence? What does it mean when it hits that? Yeah, that's the piece of this that I'm really profoundly.
Well, it's the ocean gyre that is, you know, one of the biggest concerns on the whole planet. The amount of plastic that's going around in gyre in our largest oceans is overwhelming if you think about it. And it's plastic; it's going to take forever to break down. So, no, it's a huge issue. There's a lot of work on it. There's now all kinds of interesting technologies to remove plastics. You can do it in rivers. You can make the barges that go around. A lot of people really trying to deal with it. Hopefully, someone will invent something that could clean up the ocean gyre, but that's a planetary scale problem. It's going to take a massive effort to do it. The more we can do it at this level, our level, like you said, up in the watershed, or everyone can do it in their town or their city or their house or their driveway or everywhere. When you go out to eat, whatever, if everybody does it. And I just spent time in Europe, in Switzerland, which has the most wonderful recycling programs you could ever imagine. And they recycle everything, and you pretty much get arrested if you don't do it. Places do it. They figure out how to just say, we're going to do it. We're going to stop this stuff from going into the waste stream as much as we possibly can. And then they make huge efforts to do it. And when I rent an apartment outside of Zurich, I get a speech that says, you will do it this way. And I'm pretty much okay. Yes, I will.
I feel like that lends itself nicely, Colin's concerns there. David put in the chat, Dr. Megan Ford of West Chester University of Pennsylvania is capturing and studying plastics from falling snow. So David, I don't know if you have anything else you wanted to share about that, but feel free to come off mute if you'd like.
But I like falling snow.
Yeah.
Find her information because I know she had a website or something, but I haven't been able to locate any publications on it. But it was something that we had actually done. So I work at Stroudwater Research Center, and in one of the education components that we do, we run merit badges for Boy Scouts. And in the environmental science merit badge, we use a tape trap to capture air particles or pollution that's in the air. And even in that, we were capturing plastics. So it's ubiquitous, right? That's the word.
So aeolian plastics.
These things have a neutral buoyancy, right?
The rubber noodles in the lake are throughout the whole water column, so they're probably there. They're basically neutrally buoyant. They're not all at the surface, so they're not too buoyant, and they're not all falling to the bottom because they're being moved around by the lake current, so they're kind of neutrally buoyant. Yeah.
So the residence time in the lake would be approximately the same as a molecule of water.
Probably, assuming they're completely neutrally buoyant and not just maybe settling a little bit or more than, not, but yeah, they will. And the lake has a high turnover time, the water residence time in Lake Champlain is fairly low for a lake of this size. It's only a few years. So yeah, there's probably quite a few then moving out through the Richelieu River.
So at any given time in the lake, we would be looking at 3 years of accumulation on average.
On average, although I don't know with the currents and all the islands and everything we have, I imagine there's some stuff that's going to stay in longer than 3 years. Yeah. But on average in the main lake, I mean, the way to think about the main lake is if it were a bathtub and it were empty, it would take 3.5 years to fill it up with all the river water in the basin. And that's what's called the water residence. Yeah.
I was unsure relating the spiny water fluid to the plastics. Were you just showing like how the most amount of certain things are questioned?
I was showing the spiny water fluid because it's an invasive species in Lake Champlain. I have a whole other talk on that, and we studied that a lot in our institute. Our lab is the ones who found it in the samples. We also found the fish hook water fluid in 2018. Those are two major things that have invaded Lake Champlain, had a very serious impact on the planktonic community. So I had them, so I brought them. So you could see what a spiny water flea looks like if you've ever heard about spiny water.
I work for the Ironic Watershed Institute. We find spiny water fleas.
And unfortunately, it probably came from Lake Champlain.
So is it not very good?
I guess the question I had was a lot of the water treatment plants that use Lake Champlain as a supply also filter their water, whether it's CE filter or some of them use a membrane filter. And when they clean those filters, I would think there should be a lot of potential subjects.
That's a good point.
Subject.
Yeah.
It'd be interesting, how many gallons did they screen or filter to obtain an X amount of plastic and segregated into your.
No, that's a good question. Less and less communities are getting their water directly from the lake, but there still are some that are still doing it.
So that's the only source we have. We've got 3 right in a row. Essex, Willsboro, and Fort Kent.
Yeah, it'd be worth to talk to them to look at their filters because they're frankly doing a similar kind of sampling as we do. They're just filtering large volumes of water.
Although they use 2 of them do DE. They can filter like a swimming pool DE. Willsboro is upgrading now for like 12 million. Thank you very much. Fort Kent, I think, of the membrane. Or quicksand filters, and I'm not entirely sure anymore. Yeah, it's definitely worth it.
So given we've been talking about neutrally buoyant particles, is it fair to think that there are other plastics which are either fully buoyant or heavier than water, and they're just...
Foam is going to be more buoyant. It can get waterlogged and become closer to neutral. But like these plastic beads are probably more dense than water. And yeah, there's a whole spectrum of whether you'll fall out like a particle and go into the paleoplastic record, or whether you're buoyant and you're going to stay and go out into the surface water, or whether you'll be neutral and be in the water column somewhere. They're probably all three of those ranges, but foams will probably be more on the floaty end, and harder plastics more on the sinking end.
You mentioned, you got that.
So are you have a way to sample the heavier ones?
At this point, our net samples are all in the water column. Our river samples are nets in the river flow, and our beach samples are after it's washed up on the beach. So we're actually not, we're asking what's in beaches, rivers, and the lake, not asking that question about the differences in density and which ones. Yeah, that'd be a different, because to do that properly, you'd have to put those out there at the different densities and then track them and follow them, which no, we're not, but we can from our plastics that we get an idea on what their density would be, you know, whether they're heavier or whether they're lighter. We know foams are going to float.
It's simple limits you want to learn about.
Yeah.
The things that, and the films are the most problematic because they're so fluid, you know, they're fluid is the record, but whatever and also they move with the currents and they're the ones that are really problematic.
I would be worried about the stuff that would go down to the sediment as well. I think there'd be some concern about, you know, organisms that live in the sediment, and like the paleo question that came up, but how much of that are we, what's that doing in the sediments? There's a lot of biological activity in sediments. So I'd worry about both.
You may have addressed this already, but did you talk about any chemicals that might be binding to these microplastics and that will either retain them or? It
depends on, you know, is it hydrophobic? Is it hydrophilic? It depends on the charge of it. But yeah, there's potential there for sure. Depending on what it is, potential to have like PCBs bind to it, or metals or other things, or even, you know, things that aren't toxic to us and other chemicals. I don't think we know much. I'm not that familiar with literature on that. I don't think we know much at all about those, the chemical nature of these and how they bind or don't bind different chemical elements. That's probably where there's a lot of work that needs to be done.
Tom has another question. Tom, do you want to ask it?
Yes, please. Tim, and I may have misunderstood, but I think I heard that a lot of the nurdles in the water column are similar, if not identical, to raw plastic beads that would be then turned into some plastic item. So if I am correct there, then somehow raw material is getting into the water. And the question is it possible that there has been a good-sized dump accident that some truck turned over and dumped 10 million pounds of nurdles into some creek that then downstream to the river?
And so we've done a little work on this before this project as part of our previous work. This is its characterization. It's basically a piece of rubber. Here's some images of several of them. They're all pretty much exactly the same shape and size. They have this same shape. You can see here one that looks like it's breaking down a little bit. But yes, we are convinced that this is up there, that they're all the same. These are akin to what you would see in your daily life as the little rubber things on a brand new tire, except they're all uniform, so they're not that, because when those break off, they'd be different sizes. But these are basically like those little rubber nubs that come on new tires after tires are produced. I don't think they're from tires. This is some kind of pre-production, is what we call it, piece of rubber. So it's going to be used by an industry to melt down to make something. We had no idea other than that where they're coming from. We just know they're in the lake.
Meet that definition. Like,
would it be possible to determine would it be possible to determine the type analysis of pre-production compound? This nurdle could have been made into PVC pipes. This nurdle would be made into polyethylene, yada yada.
This is going to be used to make something out of rubber. It's a piece of rubber. So okay. It's not going to be PVC, it's not going to be polyethylene. The beads will be more of that. This is going to be used to make something that's rubber in nature. Or it's being shipped and maybe, could be spillover from rail cars that come through with this in it. It may not even be being used in the Champlain Basin. It's just as railroads move through, these things get in the environment. But I don't know that our project will get to figure out exactly what these are or where they're from. But once we know their distribution in the lake, that will head us in certain directions if they happen to be concentrated in a certain part of the lake. It looks like preliminary evidence is that that's not the case, that these are lake-wide, and there are different densities of them throughout the lake, but they are, so far, I think we found them in almost all of the lake sites, being moved around by the currents, because like we just had a big discussion about they're neutrally buoyant. They're floating in the water. You see these ones in this, it's in probably ethanol, are floating all the way to the surface. The ones in the vial I passed around, I think had all settled to the bottom. But yeah, this is one of the spawning sort of reasons for this study is that we've been finding these. I don't know that we're going to figure out where they're from, but we're going to at least figure out their distribution and their, how dense they are, how many are there, should we be concerned. We already know from FTIR that they're basically a piece of rubber.
Yeah. Are you filtering samples? Are you measuring down to a certain particle size?
Good question. So all of our net samples, the mesh size on the net is 250 microns. So these are caught in a 250 micron mesh sample net. Same with the river tributary net. And then the sieve sizes, I'm forgetting on the beach stuff, but we have multiple sieve sizes that we filter down through. And that's a good point about this study to make is anything under those net mesh sizes, small, tiny fibers, things under 250 micron, which are the micro of the microplastics, are not part of this study because they're going through those net sizes that are already being used. So yeah, there's even smaller scale plastics left to be discovered in the lake. But yeah, these are in a net that's 250 micron mesh. We have a scale here, so we know the size of this. These pieces.
Got a couple more questions online. We are at 7:30, so
yeah, we're gonna be here all night.
But Rachel, do you want to ask your question first, and then you can ask after?
All right, I'll be quick. Thanks for staying. I just wanted to add, how plausible it is what the last question asker said. So for us, and you had a slide, Tim, where the bottom two pictures were resin pellets, the more hard plastic, pre-production, pre-consumer industrial items. And so we find them over on the Vermont side, and we know there was a brush bristle factory in Pine Street, so just south of Burlington, like in South Burlington, well, on the south end of Burlington City. And we know that they were transported in open rail cars effectively. And where dealer.com is, there used to be that brush factory, and there was a hopper, sort of a thing that went over the street and vacuumed up or sucked up the resin pellets in the open rail cars and brought it over to the factory over on the other side of the street. And so we think that was one of the potential sources. That factory was around when we moved to Burlington 20 years ago, but moved to Vergennes and then closed altogether. And I see somebody in the chat said there might have been something in the Willsboro area related to plastic manufacturing as well. So certainly that is plausible, that they're being lost in transport, that they're being transferred from the supply chain into the environment in the watershed and then just swirling around once they're in.
That's entirely possible. Like if these are transported in open rail cars, so they're going to bounce around and spill out. So that's entirely plausible, especially given the length of rail that we have along the lakefront and the amount of industrial rail that we have.
It could be heading to Canada. Like you said, it could have nothing to do with specifically towns along Lake Champlain. So it'll be really fascinating to see if we can figure it out.
I don't know that we will, but we're going to try.
Guy, go ahead.
Yeah, I'd like to expose some sort of answer to what Mr. Metz has asked. We got a case here in Quebec, not on the Champlain, it was on the San Francisco River, and that company used plastic for over 15 to 20 years, and they used to pack their new beads in their outside storage. So every year when they would push the snow, all those beads would get on the ground. They would integrate the ground and will slowly move towards a brook. And we started to see that contamination. And at one point they redid their storage area, put asphalt, put a drainage system, and boom, from one day to another, we had a contamination, a visible contamination that we were able to retrace. So that contamination could come from many years ago, and it's just slowly moving towards the lake, and we might not be able to find the source.
Yep.
Oh.
Okay, there's one more hand on line, and then we'll call it. But Helen, do you want to ask your question?
Oh.
Yeah.
Hi. I just wanted to ask, and sorry if you already mentioned this, but I just wanted to ask, what's the future of this project? Will the study become like seasonal, yearly? Will you be considering other environmental factors to study like changes in concentration, like maybe over time because of rain from different locations? Seeing how like maybe proximity to like Plattsburgh versus a little further due to environmental including environmental factors, like what's the future of this project?
That's a good question. I think our first goal is to just figure out where things are. That's the goal of this project, lake-wide, across the tributaries, across the beaches. And like I said, our second year is going to focus in on some sites more intently. And then after that, depending on our results, we'll probably have all kinds of other research ideas about, where it takes us from there. Focus on a particular place or a particular, as we've talked a lot about tonight, a particular type of plastic, and try to get a handle on that issue. The ones that we see are maybe the most important issues, well, particularly for the public, but also for the health of the lake. So we don't know exactly where we'll go from this, but we felt like that at least someone needed to look at how our plastics distributed on our beaches, tributaries, and lake, and then go from there. And we know there are some there, and we'll tell you a lot more about that in about 2 years when we have a lot more data on that lake, thanks to the basin program, lake-wide.
Well, thank you so much for enlightening all of us and giving us so much to think and worry about, frankly, but that's all right. Big round of applause for Stan. I saw some areas of potential collaboration with the CAC as this project moves forward, related to the citizen science and debris collecting, and also helping to engage municipal leaders and businesses in limiting plastic production pollution.
And school kids.
Yeah, and school kids. So please keep us.
They're the ones going to help solve this issue.
Keep us informed and involved about how the CAC can help move these things forward, and we'll look forward to updates as the project progresses. Folks in the room, if you're not already on the New York CAC email list and you're interested in more informational presentations like this on a variety of lake topics, there's a sign-up sheet in the back to get your email on there. Folks online, I put my email in the chat if you'd like to join that notice list. Walt, do you have any closing remarks as chair? He's still on there, but we'll give him a minute.
You're snoring. Waking up.
And that's all right if not. Okay, well, thanks everyone for joining us for the first, I think, of many New York CAC and the Basin Program Love the Lake presentations. Hope you all learned a lot and enjoy some desserts on your way out. And have a good evening. Thank you.
Thank you, Katie. Thank you, Tim. That was a good one.